Hi everyone, welcome back to our YouTube channel SID Education. In our today's video, we are going to discuss about space complexity of quicksort. In our previous video, we have already discussed about time complexity and we have seen that how this time complexity varies between best, average and the worst case. The same it is going to follow for the space complexities also. When I talk about the best case, when I talk about the best case, here what happens basically, if you remember, we had the time complexity of n log n because at every time we were dividing the array into two equal parts, right? In that case, is there. So as a result, you can write as a result of balanced partitioning, balanced partitioning that is equal halves, right? We were talking about equal halves leading to balanced recursive tree. If you have remember, right? If I have n elements, so I will get n by 2, n by 2, then again n by 4, n by 4, n by 4, n by 4, like this. So recursive tree with what call stack? With call stack of size O of log n. Now the same thing is for the average case, because in average case what will happen, you might not get exactly the equal subarrays, but you will get, instead of that, you will get equal, or you can say two partitions. I'll say two partition which may not necessarily be the equal, right? So it follows the same here for the average. Instead of n by 2, for example, if you have 5 elements, so it may happen that at one side it is only 2 and other side it is 3, right? So it is something like not exactly n by 2, but it will follow the recursive tree with the call stack size of O log n only, right? So for this also it is log n, correct? Now, what is for the worst case scenario? Worst case scenario. What do you think for worst case scenario? If you remember, worst case scenario happens when you consider the largest or the smaller element as a pivot element, right? In that case, the situation, if this is n, you just need to solve n minus 1 in the next iteration. So here, you don't get the balance partitioning, right? So you get a skewed recursion tree. If you remember that if you have n, either you will get n minus 1, then 0, n minus 2, then 0, n minus 3. For example, 5, 4, 3, 2, 1. So if you take 5 as the element, pivot element, so you will get 5. Then again, you need to, at your left position, so if this is, I consider n, so your left becomes n minus 1 again and 0, right? If I take 1, 2, 3, 4, in that case, first element is pivot. This holds true. So this is what, right? So you can write for the worst case, as a result, worst case happen as a result of unbalanced partitioning leading to a skewed recursion tree which requires call stack size of O of n. So you need space of O of n for the worst case.